Hey, so cool.
Uh, Hi, Drew. How are you doing?
Doing pretty
Yeah, yeah. Good morning.
Hey
a little,
folks, morning.
Hi, Yogesh. Good morning.
well, yeah, it's a little early in the morning, but you know, I'm waking up. Although I normally would be flying right now, and I'm glad I'm not today. There's gonna be thunderstorms here this afternoon.
Yeah.
So
Too much rain. Too much rain all over the bay.
yeah, yeah, we need it, but it's not good flying weather. Yeah.
True,
Yeah,
true.
it's funny that we are soaked here in Houston as well. Same time, same system, I believe, maybe.
Oh, wow. Nice.
Yeah,
Hey, Theo.
I
Theo.
think that
I just say
I think
hi to Theo,
oh,
Anil,
oh,
Ankit.
Theo's here. Yeah. Hey Theo.
Anil is here, Ankit is here. Good morning, folks.
Morning.
Good morning. Good morning.
That's great.
Good morning.
Good morning.
All right, I'm gonna pull up my topics spreadsheet here. So I guess we had a couple of topics today. Um, one is so the one topic is alternate internal ECC logging for fleet reliability, and I've been working with Adam on that, but we're not quite there yet. Um, so I'm not quite ready for that. And then I also had analyzers in time for the RAS API. And so I think what I'd like to do is show you all kind of a RAS API flow that we're putting in the document, but it's pretty high level. But talk about what this time series would look like. And I was just talking to Rama yesterday, and inside Microsoft, we're trying to get ready for time series analyzers, and we want to be ready to intercept them, and we want to have a plan for them because we know that you can't really diagnose memory from a single error, and counting errors doesn't work nearly as well as looking for patterns of errors. So anyway, maybe we can start with that today, and then I can talk a little bit about what Adam and I have in mind. Are there other topics we want to cover today? Okay.
Not that I'm aware of. Anyone else? Any opens today?
Well,
Any
that's
updates from industry? Anything else want to discuss?
Just want to announce that there is a JDEC forum next month. Um, I don't know if anyone in this call is planning to attend. If you are,
What is the JEDEC forum about? Is it their annual thing?
yeah, I think they do maybe quarterly or maybe twice a year, where all the memory experts, those who have interest in memory, they join. It's open. You don't have to be a JDEC member.
Oh, really?
There's a small fee, and you can join, listen in, interact with the various DRAM vendor experts and SOC experts, and all. Basically, it's a community event. So I will be
Anyone,
speaking. Mhm.
Really? What are you thinking about? Sorry.
Yeah, how we design memory subsystems in our meta infrastructure. What are the requirements? How we decide things like that.
Anil, could you throw a link into the chat?
Yes. Actually, if you go to just do a Google search for JDEC Forum 2026, you will get that. But I'll put a link here. I'm not in front of my computer right now, but I'll put it once I get there.
Yeah, actually, I see it. I'll put the link in. Thanks.
Cool. Yeah. It's a 2-day event. First day is client, mobile, auto industry, and second day is all server AI stuff. Yep, that's what it is.
Thanks for the link, Nita. Thank you, Anil. I wonder if Ivan is aware. Ivan, you aware of that? JEDEC forum? You're probably closer than anyone else here with the JEDEC.
Yeah, my team doesn't work super closely with the JEDEC things, but yeah, it has come across. When did you say that was, Anil?
May 12th,
May 12th?
13th.
Yeah, I did see that come across. I'm sure we'll have some people from our architecture team there.
Yeah, it's a small fee, $50, but I think it's worth attending in case you want to hear, understand what's going on and what's the future DRAM vendors guys are thinking.
$50, man, they really want to keep DRAM cheap, huh?
I think the fee was decided a long time ago. Otherwise, it would have been 500, 10x.
Maybe it's the same thing they've sold out for 2 years.
Well, hey, the prices are coming back down. But anyway, okay, this sounds good. And if anyone's traveling to attend this, maybe we can have a get together of this team, just informally, meet somewhere and say hi to each other. Okay. Here's what I wanted to show. And we'll zoom in a little bit. This is very simple, but we're putting this in the RAS API, but it shows how we're thinking of building the time series analyzers with RAS API. The way we have two people in the waiting room. Let's see. Oh, you're gonna let him. You're letting him in. Okay.
Yeah, I turned on the chime because otherwise we just miss people. So I don't know. I keep resetting this thing and it keeps going back to. I guess there might be OCP default or something to force people to be admitted. I don't know if you have a solution, but right now we're just manually doing
Well,
it.
I've turned it off, live in the meeting.
I did too, but that comes back every time. It defaults back to, yeah.
Yeah, I'm just saying, well, maybe we turn it off in the meeting, so it doesn't. But yeah, we have to.
I think it has to be like every meeting. That's okay. Yeah, let's move on.
Okay. So I wanted to talk about this and what our plan is for time series analysis. And so we have commands get CPR and you get a CPR back. And so in the context of memory, what we want to happen is when we call get CPR to get as much information as we can as listed in the FMFM document. And really we'd like it all. So that includes PMIC data and the syndrome information about which bits were flipped. And so we get that in a pile of data. So we call it get CPR. And this get CPR may end up being a push. In fact, pretty much everyone at scale does not like to poll. So there'll be hey, give me I'm registering interest in CPRs, get CPR, and then, CPRs will come from it. But for simplicity's sake, I'm showing, a command and a response. when we call that, the collection infrastructure will add that to the CPER history, and then it will send the new CPER and CPER history to the CPER analyzer. And in this particular example, memory would be a perfect example. We get the first CPER, and there's nothing to do. And just a good example of that would be, if we had a radiation strike, we could have a burst of errors, and we can't assume that we have a failure just because we had an error, because there's no repair for a radiation strike. So we'd say, well, there's no action. But if we call get CPER again and get another CPER, and we look through the history, what we're imagining the analyzer is doing is, looking at the newest CPER and then saying, is there anything relevant in older CPERs that might help? And look through the older CPERs. And that keeps the analyzer stateless, and it means that we can build cloud software with it. Like if the analyzer fails, we can move it to another node. And so we what we'd like to do is get these series of CPERs, and eventually the analyzer decides that it wants to do something about the error, like a self-repair. And so then it sends a CPAD to our policy tool. Our policy tool would look at the analyzer that the silicon teams provided and say, okay, this is the Intel Micron, analyzer. It's accurate. We believe that this is the right action. We'll let that one through. And so then we send it to the RAS endpoint, and the RAS endpoint will acknowledge the CPAD, acknowledge receiving it. But then sometime later, we'll call get CPER, and we'll get a platform action event CPER. And the platform action event CPER will be what tells us that the action succeeded. So, for example, if this was if this CPAD was a boot time post-package repair, then it may be some time before the machine reboots and we get this platform action event. But what we've done is we've made it so the platform action event that tells us the status of the CPAD it's easy to correlate. It contains the CPAD basically in it. So we can tell that, oh, this CPAD worked. And we might get a success here and say, oh, good, it looks like it worked. But if I call get CPER again and start getting the same error that I was getting before, then I might determine that it didn't work. And so, this is something we want to work with you all on time series analysis, because we believe we can, figure things out like this with you. Go ahead, Mita.
Yeah, so I was wondering, in this diagram, what's the trigger for get CPER? Like, what causes that to be?
That's a really good question. I was showing it as polling, but like the redfish mapping of RAS API, what you'll do is you'll register for redfish events. So you'll say, give me all the events with these message IDs, and there'll be one message ID per queue. So you subscribe to 4 message IDs: corrected, uncorrected, or deferred, uncorrected, the event queue, and information. And so this get CPER would become, I am registering interest in these CPERs, and then the endpoint would just send them when it got them. So,
okay, so like the platform action event CPER, the one at the bottom, that would fall within that like polling model category?
we'll handle all CPERs the same way. They just, each queue will have a different message ID. And this is in what we're calling the event queue. And the event queue is things that aren't errors. Yeah, they're
Yeah,
not,
that's what.
but they're
Yeah.
they're relevant to hardware errors. So yeah, exactly.
So I mean, like the idea is that the collection infrastructure at some interval um, asks for CPERs. Is that it, of a certain type?
If you want to poll, and polling will be supported with Redfish because you can the seepers always go in a message queue that you can poll. But there's also Redfish eventing, and so this is why when we talk about RAS API, we talk about it conceptually in the RAS API spec, but when we talk about the details, the details will be in Redfish. So with Redfish eventing, again, you register interest. You say, hey, RAS API endpoint, whenever you get a CPER, send me the CPER in an event. And so then it comes as an event. But I'm just showing the polling model because it's the most easy to understand. But I could
And
probably,
I believe, Drew, you are not, you're highlighting only the RAS API primitive commands here, and of course, structures like CPERS and CPAD, because we did also talk about other acknowledgements, which Redfish and PLDM may be using, but that's not where your focus is here in this diagram, right?
right. Well, and I mean, yeah, but if me to, I just want to, address any concern. We will support eventing. So yeah, but it's just not shown here exactly because you said we're dealing with the RAS API primitives. And so you
Just an observation, Drew. I mean, I understand the intent of the lowermost get CPER. You're trying to show there may be a delay between put CPAD and action event CPER. Just a preference. I think you want to show you want maybe think about it. The get CPER that is between this put CPAD and platform action event CPER seems a little distracting to me personally, at least. Just a little feedback here.
well, it's just a CPER. You have to get it the same way you get all the others.
No. What I'm saying is you are trying to demonstrate that once you put a CPAD, you get a platform action event CPER in response to that CPAD, right? And this get CPER in between the two is a little distracting. That's all. Yeah.
Yeah, but that's actually really important because
Oh, because you're saying it's a pull model, you still have to do it. I see.
well, it's really important. Put CPAD might put the CPAD today, and then 2 months later, we see the platform action event when they reboot the machine.
Yeah, that's true. That could happen.
So that will be, I think that will be a fairly common thing, right? Is that for certain RAS actions, there will be a precondition that has to be met. And, sometimes it may be that the OS needs to migrate off a core, if we want to do core sparing or something. It might be that we need to reboot a machine for our hard post package repair. Or if we're doing a runtime post package repair, it might be that the previous runtime post package repair has to complete before we can do the next one because there's some resources in the memory controller that are needed to do the second operation. So it's going to be really common to have a prerequisite for a RAS action. So like the timing between putting the CPAD and getting the response for the action will generally be separate in time. Go ahead, Nita.
Yeah. I'm kind of just wondering, like you said, the platform action event CPER could happen 2 months later because of the reboot. But my mental model was a little bit different because I thought we talked about the platform action event CPER indicating that the action will be taken on, like, on a reboot, for example. So in that case, it's not like it's not like you have to wait 2 months for the platform action event CPER to occur, you should be getting something back after the CPAD indicating that the action will be taken, potentially later. Is
Yeah,
that not?
that's not a CPER though. That's a and I don't
I
know
thought
where
that was, yeah.
it's not a CPER. It's a
No. So no, do the two things. You're talking about the transaction acknowledgement. That's transport layer. We're not talking about those here at all. But I think she's right. We did discuss that there would be platform action event
Inferred.
CPER, which may say that this action will be deferred and taken later. We did discuss that. So
it
Mita
could
is
be. Yeah.
right.
That's absolutely right. You're right, Mita. And so you could get multiple platform action event CPERs. Yes.
Okay.
No, you might get multiple. You might get one depending on the timing. We haven't really.
Yeah, my mental model is that you'll get at least one back in a relatively
Yeah.
soon after the
As a
CPAD
response. Yeah, as a response, right?
as an indication of success or as an indication of deferred action, which would be like a
Right.
reboot or yeah. And then that was my mental model at least. So,
Yeah, you're right.
Right.
You might, and um, I don't think in this example I was trying to cover that, but I think I will make a mental note to show that in another. This is supposed to be kind of the most common case. But you're right, and so I'll make another drawing with a different scenario and show that, and I can just say, that we have a long-standing prerequisite, so we get an early status back, and then we get a later status back 2 months later.
and remind me if this is correct, but I think we call them informational CPERs or something else. I don't know whether they were called like maybe that was the one that I was thinking about. Like,
They are called platform action events.
oh, okay.
Yeah, they're defined.
Yeah, I think informational is what we use for queue nomenclature, right?
Right, and this is in the event queue, not the informational queue.
Oh, okay, yeah.
So, hey, Drew, just a thought. I think when the last step, platform action event CPER, which says acknowledging the, let's say, PPR, I think that message, in my opinion, should go all the way to the policy agent and triangulate that, okay, I made a request and I have a confirmation that the message has reached.
Well, it doesn't. No, we don't do that. But directly. That wouldn't quite how. And if that's a hyperscaler choice at that point. But see, since it's a CPER, and you raise a good point. Gosh, my computer's. I'm not doing this anymore. I've let go of the board, and it's still moving.
Because,
Like
I mean,
RAS
Oh,
API is in auto mode. RAS API is
okay.
working.
API, the AI took over. No, I mean, since it's a CPER, it just takes the flow of a CPER and goes to the analyzer. If you as a hyperscaler also wanted to recognize that it was a platform action event and send it to your policy tool so that you could, the policy tool is hyperscaler dependent. Hyperscalers put what they want into it and they feed what they want into it. So if you might feed CPADs to it, but you might also feed information into your policy engine about the workload that's running. And you might reject a CPAD depending on the quality you believe the CPAD has and the workload that's running. You might decide that for this workload, I'm willing to take a performance hit. It won't hurt the workload. But for another workload, you might say, if I'm doing something that's you're going to reduce performance is unacceptable, I'm rejecting it. So the things that feed into the policy engine are very, very, very much hyperscaler dependent for the hyperscalers use cases. That's kind of the point of it, is that gives the hyperscaler the ability to make their own decisions.
Yeah, so one more thing, sorry, Drew. So the agent running in the infrastructure, okay, and the policy, let's say database, they're two different entities, or maybe two different entities.
What's the agent running in the infrastructure?
Yeah, ultimately the agent who is responsible to issue an action, or an agent who is responsible to collect the logs, okay, the, that agent is not the same as policy database. I'm just thinking out loudly. I don't know if when you say
That's
policy,
true.
you mean like it's a policy database, right?
It's not a database.
Sorry, policy is not a database.
No, it is a thing that gets a CPAD and decides whether to do it or not.
Okay, so this is this agent running in the infrastructure along with the policy together.
Well, the collection infrastructure will keep a history of CPADs and pass things around, but
Yeah, that's the intermediary, right? Its job is to, either poll it or to event, get the information, pass it on to analyzer. That's it. It
yeah,
doesn't do
but
anything, right?
I'm trying to be as absolutely specific about how you implement that as possible. So I'm just putting the minimum in, and the minimum this has to do is collect CPRs and keep a history and feed them to the analyzer. That's like the bare minimum. And the policy engine somehow has to be able to get a CPAB back to the RAS API endpoint, but I am not telling you how to do it. If you want to go through the collection infrastructure or if you want to have a separate path back, it is entirely up to you. See what I'm saying? We don't want to specify that. You have the freedom to do it however you want.
Right. So here we are not specifying how to do it. What I'm saying is that whosoever is the agent that is putting the CPAD to the machine should get an acknowledgement all the way to the acknowledgement has to come back all the way to the agent who actually put the CPAD. If you terminate in between, then the agent doesn't know whether um, the CPAD action really got acknowledged or not.
Well, that is your decision. The analyzer will see that the action completed, and it could see that the action failed and send another CPAD and say, oh no, the self-repair failed. I better ask to replace the part. And the analyzer is in a better position to take first crack at that because it knows all the features, especially the proprietary ones, and it knows what it means when they fail. And so it would actually, and we can do it, that's a different example, but if there was a failure in a CPAD, then the analyzer might send another CPAD saying, hey, replace the part. So the policy engine doesn't probably get it directly in most cases, but if you want to do that, nothing's stopping you.
Yeah,
That's,
I'm just
that is
thinking
entirely,
loudly that logically speaking, when the agent that sends an action is the agent who should receive a response somehow. Otherwise, the agent is still lingering there, has no clue whether
right.
the action was acknowledged or not. That's all.
So, Anil, I think what Drew is trying to say is you can do that. You can do that in your infrastructure, but RAS API spec doesn't have to show it that you should do it this way. That's all, right?
No, we are not
You
about
can,
RAS API here, right? RAS API
no,
is
no, no.
very limited.
This is a RAS API flow, and what you're saying is in my infrastructure, I want the policy engine to see acknowledgement for CPAD, what happened with it, and you can do it.
Yeah, and a lot of people will want that. It's going to be a common thing, but the originator, the actual originator of the action is the analyzer, not the policy engine. The policy engine didn't have a bright idea, oh, I'm going to take action on an error. It got something recommended to it and it said thumbs up or thumbs down. So that's why I'm saying the analyzer in the RAS API flow gets it first. And then if there's a subsequent action to take, you send it back to the policy engine. But if you wanted to send this platform action event CPR to the analyzer and you want to recognize that it's special and also send it to your policy engine, yeah, have at it. It's fine, but it's not required. The basic thing is all CPRs go to the analyzer, and the analyzer spits out CPADs when it knows what to do, when it has an idea.
Anyway, I'm just speaking loudly here. That's fine. Keep going.
Yeah, and nothing's stopping you from doing what you want to do. But this is just kind of an example. But this is but the key here is that the analyzer. The main reason I wanted to show this drawing is because the analyzer will see a breadth of history that it could not see before. And so I want to seed the thought in memory vendors' minds and in CPU vendors' minds and GPU, Theo, that we'll be looking at a history of CPERs. And the CPERs will contain error data. It will also contain what happened in the past in terms of action. So if this sequence were to continue, we would have another, get CPER, and we'd have new errors and new things to analyze, probably from this, machine. And they may be different, completely different FRUs. It may be the same FRU. It may be that after you try a couple of self-repairs, the analyzer goes, nah, I'm not going to keep repairing this. It's a losing battle. I'm just going to tell them to replace it. So this is the kind of thing I want folks to think about is, like how do you decide when a part needs to be replaced? And let me just, if I could shout one thing from the mountaintop to the CPU and memory vendors, this is in your interest because you get a bigger say than you do today on when parts get replaced. So if you do a really good job on this analyzer, you could potentially make your warranty costs substantially better by optimizing the repairs. Because sometimes, today we have a fairly high rate of no fault founds with DIMMs returned, and I've seen that pretty much everywhere I work. And if you all write a good analyzer here, you could really improve your warranty costs by a significant amount of money. So I'd like to think about that. And we're at Microsoft, we're getting ready to run analyzers like this. I know other hyperscalers are also making plans here, and some can actually probably do it already. So what do you all think? I mean, and what I'm looking for is like memory people and CPU people to say, okay, this is, I'm tracking, this makes sense, or oh no, we're not planning to do this. So, Yogesh, I don't think this should be too much of a surprise for you.
I think everyone other than maybe Ankit and Ivan Stuti, has been part of RAS API discussions. So, yeah, this is no surprise. But I think it's important that, in terms of expectations from the analyzer input and output that we have been discussing in this forum. So that's thank you for connecting those dots. I think that's critical.
Thank you. And that's a good word for it. That's exactly what I'm trying to do is connect what we're, the big picture with what we're doing here. So, Evan I'm not trying to put you on the spot too much, but, does this make sense to you? Are you following the concept?
Yeah, I think it kind of follows what we've been thinking too, Drew. Yeah,
Okay.
I mean, most of this is stuff we've kind of talked about before, right? We just didn't really have it in this chart.
Yeah.
We've had a lot of debates about what's policy and what's recommendations and et cetera. But yeah, I think this kind of follows all that.
Okay. I want to make it, clear. And I think like the memory analyzer would be generating CPADs effectively, or telling the CPU and, like the CPU to generate CPADs, the CPU analyzer, because it may have RAS features like runtime post-package repair.
Yep.
Yeah, the analyzer is basically a broad term. It will be whatever SoC analyzer which has wrapped within it various DRAM vendor analyzers and so on, right?
Yeah, it'll be the framework we've talked about in this meeting. Exactly.
What is different here even is this is from RAS API spec that is being developed. So that's why I meant to say when I said connecting the dots. So these commands are being defined, data structures are being finalized. So whatever we've been discussing here is what Drew is doing here is trying to make sure that we're still aligned and also everyone is aware of development in the RAS API spec.
Yeah.
Yeah, thanks. I appreciate that, and I think this makes sense.
And I think if we can kind of like make it common enough, that's the beauty of the RAS API is it's a pipeline with a clear flow or a clear way to get CPERs and put CPADs. And then but CPER is just a binary data structure, and so is CPAD. So we can make the CPER as rich as we need it to be. And also the same with the CPAD. You know, if you have a pretty elaborate feature you want to drive with it, you can build a CPAD to drive it. So, but if we standardize those flows among the hyperscalers, then I think it'll make it easier for us to all make investments in the flow. And that's really what I'm asking. So, is for you all to make an investment in the flow. So, Sakul, Roy, Ankit, do you all track with where we're heading? Stuti, is any of this a shock to you, or is this making sense?
True. Yes, thanks for explaining. I think it makes sense to me.
Okay. Sounds good. And go ahead, Yogesh.
No,
I think it's Sakul.
yes, it makes sense.
Oh, I'm sorry, Sakul. I thought that was Roy. Go ahead, Sakul.
No, it makes sense too. Yeah.
So, okay, and Roy was one of the early people that came to me and said, Drew, you can't count memory errors, and I always agreed with him. But so Roy, hopefully this is not counting. This is looking at data and drawing patterns out. So hopefully it doesn't shock you. So what I'd like to do is try to figure out when are we going to have these, and even if the RAS API is not, out there perfectly, we're getting the first version of the spec out shortly that we could implement that shows all these things. I think we would also like to start trying out analyzers. So if, this is kind of what I'd like to do is ask you all to go back and think about your plans for analyzers and when you might have something for us to try. And we might not be able to discuss it here. Oh, thank you, Roy. So even if you can't discuss your roadmap here, I think it would be helpful if you could prepare to discuss with your customers plans here so that we could make sure that we're ready to intercept what you're doing, because we have dependencies on each other, right? And so I don't know the best way to proceed there. Does anyone have a suggestion on how do we take the next step?
So, Drew, the proof of concept Microsoft was working on, there must have been a mock-up of a analyzer,
Yes.
right?
And we
I
are
was wondering.
we are doing that.
ahead.
Yeah. Sorry, I was just going to answer your question. Yes, you're right.
Yeah, so I was wondering, maybe to make it easier for the silicon vendors and the memory vendors, there is probably like a common template that, like there's some part of it that's just going to be common. Internally, the analyzer is going to do whatever the memory vendor would do for their particular silicon, but there's probably like some kind of wrapper around it that's RAS API specific. That might be a good thing to just share out with the silicon vendors as a start. I don't know.
Yeah, ours was pretty crude. It was for the demo. It was heavily. It was like a Python file. It wasn't even that we called like called functions from. But I mean, that may be something we want to work on, and maybe we can work on that a little bit here. So because we have the most complicated analyzer requirements here, I believe, because we have.
So, Drew, sorry, maybe I missed the question a little bit. In terms of deliverables out of this forum, what is the question again?
When are we going to get analyzers? And what's the next step in getting analyzers and doing proofs of concept? And so we've got the idea. I think people agree with it, and so we know where we want to go. I'm just asking how we get there, and I don't know the answer. So I'm like it's kind of an open-ended.
Yeah, I think that's more of a individual vendor level question, isn't it? Right? I mean, we're not going to deliver analyzers out of this FMFM program, right?
Right. We could make a common framework if people wanted.
That would be ultimate goal, but I don't know if we're there. Yeah.
Yeah, I don't either. I don't know if that's the next step, or we just let the vendors,
No,
propose.
I think there is a lot of, I mean, of course, memory vendors should speak for themselves and silicon vendors, but I think from what I understand, there is there are products on the roadmap, in the execution, in development, and then there is legacy. So it is not a clean slate where we can just start, and everyone will have different approach in general, depending on what's going on with them, right?
Yes, yes. So, so maybe what we need, what we Microsoft could do is reach out to some of the vendors and say, who's ready to go, and try a proof of concept with someone. I don't know.
Yeah, that's right. But actually, that is a good segue into something I was thinking about in terms of what next for FMFM. Right. OCP has certain expectation, right? So this is good. We're solving problems. But do we want to discuss any next spec or deliverable plan? It may be a white paper on how to implement RAS API for memory subsystem kind of thing. That may be a good bridge. What do you think? What does everyone think, really?
So, by the way, here's the future workstreams. Can you see the tab I'm sharing?
Yeah, no, the topics I know. I was talking specifically about what do we deliver. Right?
Yeah. But I mean, like we can add it. I was just going to propose, let's discuss it and add it to this, and this may jog people's memory. You're raising a good question.
So I think it could. We can decide how we want to do a spec-like document, or we want to do a more implementation guide kind of document where we have fill in more details about the data structures from RAS API, about the methods that it should be transparent at the DRAM vendor analyzer level, but about the methods that are being used for transport by Redfish or PLDM, we can mention those. I think the idea, what I'm trying to do here is to educate DRAM vendors more and take them to the implementation stage of RAS API analyzers for RAS API rather, right?
Yes. So I like, if you look at the next topics, I think we need to think about DDR5, HBM-LP. We kind of have that listed. Maybe an LP6 logging review. But then in that, I think you're right. Do we have I don't know if we want to make a memory error analysis document that shows the details of how you map things to subword lines necessarily, but we could have a more detailed walkthrough of how the CPU and memory analyzers work together. Or we could even have a prototype framework that shows what that would look like. I'm not sure what makes the most sense. So next week we have, or not next week, week after next, we have Roy, who's going to give they have their proposal for logging, and then after that, I'm still working with Adam on an alternate proposal, and I think he's talked to Anil about it as well. But then you're right, Yogesh. Like what's next? What do we like in terms of the memory vendors? You know how I wrote the poison document explaining the value of implementing poison correctly, and then like the requirements for poison and how it works. We could write here's why counting is a bad idea, and you should use these analyzers instead document that walks through a couple of example memory scenarios in a very general sense, no proprietary data, and say, look, what the historic way of doing this is pretty bad. Here's a better way. But is that what you were talking about, Yogesh?
Yeah, I think I wanted to focus back a little bit on what is most useful next deliverable out of. I mean, we have been discussing for past 3 months, 4 months, some really good topics, and it's all coming together with hardware fault management framework and now RAS API commands and data structures, and ability to use the underlying existing industry standard layers from DMTF. So how do we proceed from there, right? So yeah, in general, you're right.
Yeah, what do you all think? I mean, like we could have like a memory analysis white paper saying why we want people to use it. I mean, let's see. I was trying.
How about like okay, so how about some discussion and maybe a white paper out of it as well, talking about so like you had that paper on why counting is a bad idea sort of thing, but in this case we could have scenarios like memory errors occur, but that it's not like you have a bad DIMM, so that could be due to one of those that you already brought up, which is poison. It could be due to something on the CPU side. And here's how RAS API kind of would help in those situations to correctly, to help identify where the actual underlying hardware problem is, even though what's being manifested in the system is just memory errors, whether they be CEs or UEs. Just thinking out loud, kind of there.
Okay, and that's the memory scenarios document, really. I'm thinking now that I think about it, right? Like we can work on the memory scenarios some more. Because that when you said that, you reminded me that we had we were working on that.
Yeah, that's true. Maybe maybe we could continue down scenarios, but then extract out something that like a common theme out of like the multiple scenarios and make it into a white paper. because
Yeah.
that could tie in RAS API into the whole thing as well. Like if we have these 5 scenarios where memory errors occur on a system, but once you analyze them, then they turn out to be memory controller issues, or like your trace on the PCB is not good to leading up to the DQ lines, or poison from PCI Express, like those that could be like a interesting angle.
Yeah, that's all good, knowledge
Well,
to
and like the
have.
scenario. Oh, sorry, Yogesh.
No, I think I was just saying that's all good addition to the existing effort in that direction. I think what we can do is we can sleep over it and let the DRAM vendors come back with which direction they need help in. Do they need help on the technical side of it? How to implement RAS API and analyzers? Or I think they have pretty good handle on. I mean, we are learning from likes of Roy and folks from Samsung and all that here. So very good handle on the nature of errors that happen inside, and also good feedback from integrators like CSPs and OEMs about what goes wrong when DIMMs fail in the field. So let's come back to it. I just wanted to draw attention. We don't have to decide at this moment, like
Yeah.
what is our next step.
We got these things down, and I see Anil type something, and Anil, the memory scenarios is pretty similar. I think the white paper and what you're talking about, the primer, probably are the same thing, but that's awesome. I think we're thinking along similar lines. So that sounds good. Okay, I like it. Let's maybe we end a few minutes early today then.
Again today. That's awesome.
Then we can think about this, for the upcoming meetings. So next time Roy is going to talk about.
Roy is acknowledged. Yeah.
And then from there, I'll also look through the scenario document, and I'm happy to start writing that again. And what I'd love to do in that document is highlight the value of getting the memory vendors help in understanding how memory fails, and how you have to filter out radiation, and how some memory errors are not that big a deal and some memory errors are a really big deal, and how if you listen to your silicon partners, you might get a better answer. And then what we'll do is set up demand for the memory analyzers, so we'll be sure to get them. That's my selfish motive for wanting to do that, but sounds good. Okay, well, thanks everyone.
Thanks. Bye.
Okay, talk
Thank
to you.
you. See you all next time.